Welcome back to my channel, Geophysics for Everyone. I do hope that you enjoyed the video. Thank you. Today we are going to talk about the measurement of magnetic susceptibility. This video is a part of a series that is intended for the second year courses at Institut Teknologi Bandung that is called Elementary Geophysics. So why we have to measure the magnetic susceptibility by ourselves? Again, ideally, geophysicists should have a hands-on experience on how to measure basic physical properties. Geophysicists should have a sense of magnitude when it comes to use the values of physical properties. And this is why at Institut Teknologi Bandung, we designed a courses, Elementary Geophysics, with a laboratory component. In this laboratory component, one of the measurement is a measurement of magnetic susceptibility. So what do we need for the magnetic susceptibility measurements? If you have seen our last video, measurements of density, you know that we are going to use the same samples. Okay? We are going to use cylindrical hard rock samples, and we are going to also measure or use the muds, the pyroclastic sample, and the iron samples. We also need the cylindrical plastic holders, and we will need the same instrument basically, a precision balance to measure the mass of the samples and a caliper to measure the dimension. But this time we need an extra instrument. The instrument that we need to measure the susceptibility is called the Bartington MS2 magnetic susceptibility meters and the Bartington MS2B sensor. So this sensor, the one in front of the picture, is a sensor. So in this laboratory exercise, you are required to determine the magnetic susceptibility of 5 different solid rocks, 1 mud samples, 1 iron sand samples, and 1 pyroclastic sample. You have measured the dimensions of the sample previously when you did the density measurement, so you know the mass and the volume of your samples. So now you just have to measure the magnetic susceptibility of these samples. How you are going to do that? You insert the sample one at a time to the sample slot of the MS2B sensor. You don't have to worry this time, okay? When you do it in the lab, a laboratory assistant will help you to operate this instrument. Just make sure that you choose mass-specific magnetic susceptibility instead of volume-specific magnetic susceptibility. Please also ensure that you do measure the sample multiple times, at least 3 times each. And then the instruments would give you the average mass-specific magnetic susceptibility of each sample. There are some cautionary notes on these experiments. For instance, when you measure the mass-specific magnetic susceptibility, there is a possibility that the values will vary greatly between one sample to another. This is okay. So magnetic susceptibility could differ by 2 orders of magnitudes, for example. That's common, no problem. So then you might expect that the mud sample would have a very low values of magnetic susceptibility, but the iron sand sample would have very high value. Please don't forget to describe and identify your rock samples so you have a rough idea about what types of rocks they are. This will help you check the measured values with that in the literature. In your report, apart from the values of the magnetic susceptibility, you probably want to discuss your findings. For instance, you could discuss why the values of magnetic susceptibility of some substance are much higher or much lower than that of the other substance. The students might also compare their findings with that in textbook or in other literature. The students might describe why the magnetic susceptibility that they measured for a given rock is higher or lower than that in the textbooks. In the next video, we will be talking about the measurement of porosity in rocks. Thank you for watching. I hope you enjoyed the video. I'll see you later. Bye-bye.